Hello, this is Mrs. Huntley. This is Module 4, Systems of Equations. We are on the last lesson, the last video lesson, I should say, applying systems of equations. So we're going to be doing some application problems, which is the same thing as story problems. So please open to this page, which should be on or about page 38, and add the EQ at the top. How do I use systems of equations to solve real-world situations? In the middle of the page, we have some, or top half of the page, I should say, we have some fill-in-the-blank notes. And let me just read those aloud to you. Applying systems of equations. Many real-world situations can be solved with a system of equations. To problem solve, follow these steps. First, define your two variables. Make sure that you're going to write them out. Number 2, write your system of equations. Number 3, solve the system of equations. And number 4, find the answer to the question that's being asked. That's hugely important because we might get our values for x and y, but not be able to apply them properly. So let's look at the first example. It says at Manny's Taco Shops, you can get an order of chips and 2 tacos for $9.25. The cost for 2 orders of chips and 5 tacos is $21.75. What is the cost of an order of chips? So we need to define our variables. What are the 2 things that are changing? And I'm going to say it's the chips and the tacos. So let's say x is going to be the amount for our chips, and y is going to be our amount for our tacos. Okay, so let's go ahead and reread the question, maybe mark our text a little bit. We can get an order of chips, we're calling that our x, and 2 tacos for $9.25. That and would be a plus, right? The cost for 2 orders of chips and 5 tacos is $21.75. Now this looks like a minus sign. It's not a minus sign here. It's a new program and I'm still getting used to it. So writing our systems of equations, this should be relatively easy with how we marked our text. So I'll have x plus 2y equals $9.25. That's our 1 chip and 2 tacos. The other one, 2 orders of chips and 5 tacos is $21.75. Now, both of these equations are in standard form. Now, we've learned how to solve systems of equations by graphing, which works great when our equations are in slope-intercept form. We also learned substitution, which is great when our equations are, when only one equation is solved for x or for y. And we learned elimination, which is the choice when both of our equations are in standard form. So with elimination, we have to look for a set of opposites. So either our x terms or our y terms have to have opposite signs and the same coefficient. Now I don't have that with either one of the x or the y. So I have to create it. So I'm looking at this and I see x plus 2y in the top equation, and I have 2x plus 5y in the bottom equation. So I'm going to multiply the top equation through by a -2, and that should create a new equation with a set of opposites. So I'm going to do the multiplication really quick. I'll have -2x. I don't want a plus. I'm going to say negative. Oops, -2x minus 4y equals a -1850. Now these are the 2 equations that I can now add together. 2x plus -2x is going to be 0. Those are going to be eliminated. 5y plus -4y is just going to be 1y, or just plain y. 2175 plus -1850 is going to be 325. So my y is 325. Now I'm going to take that value and plug it back into one of the equations to solve for x. Now I'm going to suggest that we just do the top one. And I'm going to go back to the original equation because the x was already by itself. So I'm going to say x plus 2. Instead of writing the y, I'm going to put a parenthesis and put $3.25 in there equals $9.25. Now I just do the math and solve. So x plus 2 times 325 is going to be 650 equals 925. Subtract 650 from both sides of the equal sign. And x equals $2.75. So what does this mean in the context of the problem? I'm just erasing these stray marks down here. I seem to be making like little dashes and stuff, and I'm not sure why. So, oh, you know what? I just solved the system in the box where it says write your system, and I knew better than that because I've actually done this a couple of times already. But that's okay. All my work, there's my work. And what I'm going to do here is just put my answer. So my x was $2.75 and my y was $3.25. What does this mean in the context of the problem? We said x was the cost of the chips, and we said y was the cost of the tacos, right? So what is the cost of an order of chips? I can answer that question now. I'm going to grab my ability to type maybe, because I think I can type it neater than I can write it. So let's try that. Oops, not then. The cost. Ooh, my goodness. Oops, dollar sign. $2.75. I have to always answer the question that's being asked, and I have to be able to understand what my x and my y are representing in the context of the problem. So hopefully that's getting a little bit easier. Let's do a couple more problems together. The length of a rectangular garden is 4 more than 3 times the width. If the perimeter of the garden is 104 feet, then what are the dimensions of the garden? So let's take a look at this. Now rectangular, I'm going to actually draw a picture of a rectangle because that helps me envision what's happening. So I've got a short side and a long side on any rectangle. And they're saying that we've got a width and we have a length. The length of the rectangular garden is 4 more than 3 times the width. So this is our length and this is our width. So we're used to using x's and y's for our variables, okay? So I'm going to say x equals the length and y equals the width. But wait, they gave us some directions here. So I'm going to replace this. We said the length was our x and the width was our y. And they said the length of the rectangular garden is 4 more than 3 times the width. Okay? So x is going to equal, the length equals, oh, I said 3x, and I bet you that was confusing. So x is going to equal 3 times the width plus 4, okay? The perimeter is all the way around. So I'm going to need 2 y's, and I'm going to need 2 of our x's, and x equals 3y plus 4. So here's what it's going to look like when we're writing our system. X equals 3y plus 4, and I need 2 x's and 2 y's to equal 104. Okay? So now I have one of the equations solve for x and not the other one. I'm going to solve it in the right spot this time. So I've got my x equals 3y plus 4, and I've got 2x plus 2y equals 104. So I'm going to substitute this in place of the x. Now substitution is what I'm going to choose here because one of my equations is solved for x, and that's going to be the best method for me to use. So I'll have 2 times the quantity, 3y plus 4 plus 2y, and that should equal 104. And I got this goofy mark here, and these, so let me get rid of those. Okay. Distribute. Combine like terms. This looks like a division sign, but it should be a plus. Now I'm going to subtract 8 from both sides. I don't know why that happened. So 8y equals 96. And it's not negative 8y. This is just a weird mark. Divide by 8. Divide by 8. And y is going to equal 12. So I'm halfway there. I'm going to take that and I'm going to plug it into the top equation because x is already by itself. 3 times 12 plus 4. 3 times 12 is 36. Or you could just do it on your calculator. So x is going to be 40. So what does that mean? It means the length. Okay, why does that keep moving? The length is 40 and the width is 12. So what was the question? What are the dimensions of the garden? So I kind of answered that, but now I need to put it in words, and I can't find my cursor. There it is. So the length of the garden Okay, so the length of the garden is 40 feet and the width of the garden is 12 feet. How do I know that? Because I define the variables, and whatever comes up in the x is the length, whatever comes up in the y is the width. That's why it's so important to define your variables and know what they are representing. Okay, we have one more that we're going to do together, and then the rest we will do in class tomorrow. So Kelly's basketball team is made up of a total of I'm sorry, I misread it. Kelly's basketball team made a total of 33 2-point and 3-point baskets in their game last week. If their team scored a total of 72 points, how many 2-point baskets did they make? So, again, one is going to be our x and one is going to be our y. So we're going to have x be our 2-pointers, number of 2-pointers. And we'll have y be the number of 3-pointers. So we have a total of 33 2-point and 3-point baskets in their game. We have a total of 72 points. How many 2-point baskets did they make? So our system of equations, our total baskets, x plus y equals 33, because that's the total number of baskets that we made. The points, so our 2x plus 3y is going to equal 72 because that's the number of points. So we have to multiply the number of baskets made by the number of points. Again, we've got both of these equations in standard form. So multiplying through top equation through by -2 is going to give us a set of opposites. Whoops, I should probably rewrite it down here. Let me undo those two things. So let's rewrite our system of equations. X plus y equals 33, and 2x plus 3y equals 72. That's our system, and I'm going to use elimination to solve them. So I'm going to multiply this top equation through by -2. It means everything in that equation needs to be multiplied by the -2. So I'll have -2x minus 2y equals -66. When I add this equation together, my x's are going to drop out. 3y minus 2y is 1y, or just plain old y. 72 minus 66 is 6, so y equals 6. I'm going to take that, plug it in. I'm going to go with the top equation. So x plus 6 equals 33. Subtract 6 from both sides, and x is going to equal 27. So again, I'm going to switch colors just so you can see the difference here. Come on now. So this 27, oh, why don't we change? This 27 is the number of 2 pointers because that's your x. Your y is your number of 3 pointers. That's your y. Oh, I guess I should write it as a ordered pair. So 27, 6. So answer the question being asked, how many 2-point baskets did they make? They made 27 2-point baskets. Okay. I was planning on setting up these equations at the bottom here, trying to figure out what we would call our variables and actually setting up the system. But these are actually very involved, and I've already gone 17 minutes. So what I'd like you to do, if you have the time between now and class tomorrow, is try to identify the x and the y. So like in the first one, find the value of two different numbers if their sum is 70 and their difference is 36. So I would say x should be your first number. And y would be our second number. If you can set up the system of equations, by all means do it. But right now, if you could just identify the x and the y, that'd be great. The next one says, Brooklyn has a combination of dimes and nickels in her wallet. She has 3 times as many nickels as she does dimes, and the total value of the coins is $4. How many does she have of each coin? So we can say x is our dimes, y is our nickels. See if you can do that for the rest of the problems before you come to class tomorrow. I am going to end the video here. Just to recap really quickly, when you're using a system of equations to solve a real-world problem, the first step that you're going to make is to identify or define your variables. You're going to just say what your x is representing, say what your y is representing. The next thing you're going to do is set up your system, solve it, and then make sure that you are answering the question. So have a great night, and I will see you in class tomorrow.